So you should have had a chance to practice a little bit with the factored form in the warm-up activity. Today what we're looking at is switching between the standard and the factored form. We did a little bit of that last week where we were switching from factored into standard, and you did that by using either the table or by using FOIL. Today what we'll look at is going the opposite direction around, so going from your standard form and turning it into that factored form. So for example, I might be given a standard form like this equation here, and then I want to turn it into the factored form, which looks like this. And those two equations are exactly the same. If you went and graphed them, you would get the exact same graph. They're just written in different forms. And you might want to do that because the different forms give you different information, right? If you have standard form, it's a little trickier to start graphing it. But if you have factored form, you would automatically know your x-intercepts, and you'd be able to start graphing it. So our goal is to be able to turn one of those standard forms into a factored form. All right, so there's kind of two ways to do it. I'm going to show you using the chart to begin with, just to kind of show why we're doing things the way we're doing them. And then later on, I'll show you a bit of a shorter way to do it. All right, let's look at our first example here. Y equals x squared plus 6x plus 5. All right, so let's think about if we were going to fill this into a chart. If we were going to fill it in a chart, we would need two brackets, right? So x plus or minus something, x plus or minus something, and then we'd multiply all those and fill in our table. And when we fill in our table, that's where we would start to get our standard form from. So we're going to work backwards. We're going to start from inside where our standard form is. And we're going to work backwards and try and figure out what are the two brackets that multiply to get our factored form. All right, let's see here. We know that there's an x squared in our equation. And there's really only one way to get that. It would be x times x. X times x is x squared. We also know that there is a plus 5 all on its own at the end. And in this case, this is where you start to run into a little bit of a problem, because what do you fill in? It could be 1 times 5 is 5. Or it could be negative 1 times negative 5, because that would also be positive 5. So how do we know what to plug in? Well, let's see here. We know that the last two numbers have to multiply to 5, right? Okay, so we know the last two numbers have to multiply to 5. We also know that these two middle terms are always x terms. They're always like terms, and we join them together by adding them. So we know that whatever those two x terms are that join together, they're going to add, and they have to give us a 6x. So they have to add to 6. So anytime you're solving these, the numbers in the brackets, they're always going to multiply to the last number, 5, and they're going to add, because those are the two like terms, to give the middle number. So even without the table, we now know that the numbers that multiply, or the two numbers in the brackets, they always have to multiply to the last number and add to the middle number. And that comes just from kind of looking at this and trying to work backwards. All right, so can we think of two numbers that multiply to 5 and add to 6? 5 and 1. I circled them because they work. 5 times 1 is 5. 5 plus 1 is 6. Okay, so those are actually the two numbers that we need. X plus 5, x plus 1. Let's fill in the rest of the chart to double check. 5 times x, 5x. 1 times x, 1x. Let's see. X squared plus 6x, because those added, plus 5. Okay, so what is our factored form? Well, we can just take it out of the two brackets now. So factored form is x plus 5 times x plus 1. All right, so at this point, we'll actually, let's try one more here. And then I'll let you try some on your own. Okay, so next one, same sort of process. X squared plus 5x plus 4. Okay, so we need to get an x squared. So that must come from x times x. We also know that we need a 4 at the end. And the 4 must have come from, ooh, okay. Well, we don't know. Right? We know that we have to multiply to get 4. But it could be a bunch of different options, right? Okay, two numbers that multiply to 4. 1 times 4, 2 times 2, negative 2 times negative 2, negative 4 times negative 1. Ooh, there's a bunch of them. So which one of those are we going to choose? Well, we know that the two middle terms have to add to give a 5x. So we know that the two numbers that we choose have to add to give us 5. All right. Can we think of numbers, two numbers that multiply to 4, add to 5? I think 4 and 1 work. That's why I circled those ones. Those ones work. 4 times 1 is 4. 4 plus 1 is 5. There we go. Now you'll notice here I wrote some other ones, and that's because sometimes it's tricky to figure out what the numbers are. So if it's tricky to figure out what they are, you just write down, just only focus on the multiplying. What pairs of numbers multiply to 4? 4 times 1, 2 times 2. I said some other ones as well. Negative 2 times negative 2. Negative 4 times negative 1. You write down all of those first, and then you go back and you circle the one that adds to 5. So then you look back through your list. You say, okay, which ones of these adds to 5? No, that doesn't work. That doesn't work. That doesn't. No, 4 times 1 does. Circle that. That's what gives me my factored form. X plus 4, X plus 1. You can fill in the rest of the chart to double check. 4 times X, 4X. 1 times X, 1X. So let's see, X squared plus 5X plus 4. There we go. That's our factored form. Once again, these two equations are the exact same equation if you graph them out, just different forms. All right, so at this point, I'll get you guys to pause the video. There are some negatives in these ones, but pause the video and see if you can try the next two out. All right, hopefully you had a chance to try those out. Let's see here. Once again, x squared comes from x times x. And we need numbers that multiply to give us a negative 3, right? What times what gives us negative 3? Multiply to negative 3. Okay, we know that the middle terms are going to add, and we know that they have to add to give us a plus 2x. So they have to add to positive 2. And now it's just a matter of figuring out what two numbers multiply to negative 3 and add to 2. Let's see. Multiply to negative 3. Negative 3 times 1. It's negative 3. 3 times negative 1 multiplies to negative 3. And I'm choosing the pair that adds to 2. 3 and negative 1 adds to 2. Okay, those are my two brackets there. X plus 3 and X minus 1. X plus 3 times X minus 1. And now we just fill in the rest of the chart here. 3 times X, 3X, negative 1 times X, negative 1X. Double check that it works. The chart, I mean, at this step here is not really needed. We already have our factored form. But you can use the chart to double check your answer. X squared plus 2x minus 3. Yep. All right, looks good. All right, and the last one. All right, we needed an x squared. That came from x times x. We needed a negative 6, and, well, that's where we have a bunch of options, right? How did we get numbers that multiply to negative 6? Whole bunch of options. Negative 6 times 1. Negative 3 times 2. 3 times negative 2. All right, we're also looking for ones that add to 1. There's no coefficient here, right? So it's like a plus 1x. Okay, so numbers that multiply to negative 6, negative 6 times 1, 6 times negative 1, 3 times negative 2. Make your list, and then you're going to choose the pair that adds to 1. So I think 3 and negative 2. Those guys multiply to negative 6. Yep. They add to 1. Yep. All right, those are my brackets. X plus 3, x minus 2. Y equals x plus 3 times x minus 2. And we'll just fill in the rest of the chart here just to make sure it works. And yep, it looks like it does give us the right expanded form. So yep. All right, for the next one here, we're actually just going to leave out the chart. Right? The chart was useful for figuring out how we're going to do it, but now it's, unless you wanted to double check your answer, it's not really needed. Okay, looking at this guy, we know that the numbers have to multiply to give that last term, right? The number in the bottom right. So we need numbers that multiply to negative 5. And we know that the two x terms, the two middle terms, will add, and they'll add to negative 4. So we just need to find two numbers that multiply to negative 5 and add to negative 4. Negative 5 and 1, those two numbers work. Negative 5 times 1 is negative 5. Negative 5 plus 1 is negative 4. Yep, those work. So those are my brackets. X minus 5 times x plus 1. All right, so I'll give you a minute if you want to pause the video and try the next one out. All right, hopefully you had a chance to try this one out. Let's see here. We'll do the shortcut method again. We are looking for numbers that multiply to give 10 and add to give 7. It's a matter of just figuring out those two numbers. I think 5 and 2 works. 5 times 2 is 10. 5 plus 2 is 7. Yep, works for both. So that's my two brackets, x plus 5 times x plus 2. If you're having trouble figuring them out, ignore the adding for a minute and just look at the multiplying. Write down all pairs of numbers that multiply to 10, make your list as big as you can, and then look for the ones that add to 7. All right, there's just one more step to add to this. You'll notice all of the ones we've done so far, they have no coefficient, right? The a value is a 1. It's not even there because we've just assumed that it's a 1. What happens if there is an a value? Okay. There's a couple different things that can happen, but sometimes, or the first thing you should look for is if that a value is a common factor, meaning that you can factor it out of every single other term. Or you can rewrite it as a multiplication with every single other term. So in this case, I notice there is an a value of 2. And I also notice that every other term divides nicely by 2. So since they all divide nicely by 2, I can actually factor out a like term of 2. I can rewrite this equation as 2 times something. Okay, so I'm going to create a big set of brackets, and I'm going to say, let's rewrite this equation as 2 times something. All right, well, let's look through here. 2 times what would give me 2x squared? 2 times x squared. 2 times x squared, 2x squared. Okay, let's look at the next term. 2 times what would give me 14x? 2 times 7x would give me 14x. And you can kind of go backwards by dividing, right? Okay, if I divide by 2, that would be 7x. Okay, 2 times 7x is 14x. And the last one, 2 times what gives me 24? 2 times 12 gives me 24. Okay, and because I created this giant bracket, that 2 is multiplying by everything inside the brackets. So this is okay. This is the exact same equation. It's just written with a multiplication. I've factored out a like term of 2 or a common term of 2. Let's go back and let's kind of expand this out and double check that we didn't change our equation. Let's see, what if you did multiply that 2 into the brackets? You would get 2x squared plus 14x plus 24. Same equation. We've just rewritten it with the multiplication. Now we haven't actually finished factoring because this guy is still a standard form. So we can factor the inside of the bracket a little bit further, just like we did in the previous questions. All right, I'm just going to look for numbers that multiply to 12 and add to 7. Numbers that multiply to 12, add to 7. Make your list of numbers that multiply to 12. Choose the ones that add to 7. I think 3 and 4 works. 3 times 4 is 12. 3 plus 4 is 7. Yep. All right, so we can change that into a x plus 3 times x plus 4. And my 2 is still just sitting out front, right? It's still just multiplying by everything. All right, so that's now fully factored, right? It involves a bunch of multiplications. Right? What does factoring mean? It means that you're rewriting your equation with multiplications in it. But it's still the same equation, right? It's not different. The graph is still exactly the same. All right, so at this point, you might want to pause the video and try the last one out on your own, and then we'll check the answer in a second. All right, hopefully you had a chance to try the last one out here. This one, it looks like everything divides nicely by 3. So I will factor out a 3 at the front. So I'm going to say, okay, I'm going to rewrite my equation as 3 times some big bracket. 3 times what equals 3x squared? 3 times x squared equals 3x squared. 3 times what is negative 12x? Remember, you can always kind of divide to figure it out, right? Negative 12 divided by 3 is negative 4. Okay, so 3 times negative 4x is negative 12x. Yeah, it works. 3 times what is negative 36? Once again, you can kind of divide, right? 3 times negative 12 is negative 36. Okay. All right, we have factored out a like term of 3. Now we just need to keep factoring inside the bracket, and this is like the last ones. I'm looking for numbers that multiply to negative 12, the last number, and add to negative 4, the middle number. That might be messy, right? If you're not sure, create a big list. Numbers that multiply to negative 12. Negative 12 times 1. 12 times negative 1. Negative 6 times 2. 2 times negative 6. Make the list as big as you need to. And in this case, once I got to this one here, I wrote down negative 6 times 2. I realized, oh, okay, those ones add to negative 4. Yep. So I'm going to circle them. Those are my 2 numbers. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. Yep, it works. So I know my 2 brackets will be x minus 6 and x plus 2. And just remember, you still got that 3 out front. And now we're in factored form.